This is a video on related rates. The question states, a balloon is being pumped with air at a rate of 8 cubic feet per minute. How fast is the radius changing when the radius is 0.5 feet? So when we read this question, we see we have cubic feet per minute. Cubic feet is a measure of volume. And we want to know about radius. So the first thing we want to do is relate the radius and the volume. Since we have a balloon, it's a spherical balloon, we can relate it using the volume of a sphere formula. And that formula is the volume is equal to 4/3 times pi times the radius cubed. Now let's look at our numbers we're given. We have a rate of 8 cubic feet per minute. The word rate represents derivative, and cubic feet is volume, per minute, minute is time. We can say that the change in the volume with respect to time is equal to 8. We're asked to find how fast is the radius changing. So how fast is a time? The radius is r, and it's the question. So we can say that dr over dt, or the rate of change of the radius with respect to time, is our unknown. That's our goal for this question. And then we're told that the radius is 0.5 feet. So we can state that r equals 0.5. Notice that as the balloon is being pumped, the radius changes. It's not always 0.5. When we have a number given, but the radius or that variable is changing, that's something we're going to use at the very end of the question. So we have a relationship between the volume and the radius. We want to get some derivatives with respect to time. So I'm going to implicitly differentiate with respect to time. And I can say that d over dt of v is equal to d over dt of 4/3 pi r cubed. Of course, d over dt of v is just dv dt. And the derivative of 4/3 pi r cubed, well, the derivative of r cubed is 3r squared. So the 3 and 3r squared and the 3 in the bottom cancel. So we get 4 pi r squared. And then, since we're differentiating with respect to t, and our variables are, we need to multiply by dr over dt. Now that we've taken the derivative, let's plug in all of our numbers. dv dt is 8. Now r, which we can use now, is 0.5. So I plug in, and I get 8 equals 4 pi times 0.5 squared times dr dt. 0.5 squared is 1/2 squared, or a fourth. A fourth times 4 is 1. So I could just divide by pi, and my final answer is dr over dt is equal to 8 over pi. Or in other words, the radius is changing at a rate of 8 over pi feet per minute when the balloon is 0.5 feet. And I'm done with the problem.